Hello, welcome to Introduction to Java Programming. In this session, we discuss about abstract classes. Let's begin. In the previous session, we understood what is abstraction and how to achieve abstraction in Java. So we have two things actually. So one is abstract class, other is interfaces. Let's begin with abstract class. So abstract class is any class with a keyword called abstract. So we have one keyword that is called abstract, which is one of the modifiers. There are 12 modifiers in Java. Four are visibility modifiers and rest are non-visibility or non-access modifiers. Abstract is such one modifier which can be given to classes and methods. Okay, so now let's understand what is an abstract class and what are the properties related to that abstract class. The first point, any class can be made abstract. So we have written so many classes so far, and if you want to make a class abstract, we can do that. Any class can be made abstract. As an example, let me show you here. So we had a class called account with instance members, one constructor, and a main method. Of course, we have some get account. So one setter, one getter kind of thing, and a main method. So this class can be made abstract. So modifiers can come in any order, abstract public or public abstract. So now I'm saying like this, public abstract class account. So we can actually do this. Any class can be made abstract. Now what I do is I try to compile this particular class account. So Java C account.java. Okay, so here I have instantiated it. So let's actually remove this main method, and I'm not instantiating this at all. Otherwise, let us assume there is no main method because I want to keep my account as a purely a business class. Okay, I'm saving this. I'm saving this, and I have made my class account. And let me actually compile this and see. Yes, it's compiled. So any class can be made abstract, and Java allows it, and it can actually uh, give us the bytecode. So if you want to see, you can actually see Java C account. So this is the dot class file. So it's compiled from account.java, and here we have one constructor and one get account method, right? So any class in Java can be made abstract. Okay, so but that is optional. So far we have written classes which are not abstract, but we can actually make any classes abstract. So I will come to that point. So why we have to make any class abstract? Yeah. So then the second point is, if a class contains at least one abstract method, then it must be made abstract. So first one is optional. Any class can be made optional. But the second one is, if a class contains at least one abstract method, then it must be made abstract. So what is abstract method? Abstract method is a method which contains no body, and it should end with the semicolon. That means there should not be any implementation details. Abstract method contains no body, ends with semicolon. That means there's no business logic in that. Just we have to specify, right? So any class that contains at least one abstract method in it, it must be made abstract. So now I will show you here as an example. Okay, so here I'm going to have a method void, let's say fun. Okay, so I'm making this as an abstract. I'm saying like this, abstract void fun, and I haven't made my test class as abstract. Let me try to compile this. Let me try to compile this. So Java C. So let me save this in the current directory. This test class is there, yeah, in the current directory. That's fine. Replace. Now let's say Java C test.java. Now let's see what is going to happen. There is an error actually. Okay, test is not abstract and does not override abstract method. That is fun actually. right? So what it's saying, test class is not abstract. So what I'm saying, if a class that contains at least one abstract method, it must be made abstract. So here I'm not making it abstract. So that's why it is actually not getting compiled, right? So now let me make this abstract. So because it contains an abstract method, then it will get compiled. Now let's see Java, see test.java now got compiled actually. So the second point is also clear, right? Yeah. So now the third and most important point is abstract classes can't be instantiated. So we cannot create an object of an abstract class. So that's what actually I tried here. So when you have a class abstract, you cannot create an instance of it. You cannot create an instance of it. So I will go to my main here. Sorry, I will get to my main class. This is my test class. Now I try to create an instance of account. So account some A1 equal to new account. So what about my account? Which kind of class is that's an abstract class? Okay, so here my account class has some account number, account type, and balance. Let me pass certain values, account number, then account type, and of course some balance is there. Right. What I'm doing, I'm trying to instantiate it. Instantiate means creating object actually. Okay, so creating object. I'm trying to create object for an abstract class. So my account is an abstract class and I'm trying to instantiate that here in my test class, that is my main class. Now let me compile the test Java C test.java. Now you can actually see abstract cannot be instantiated. So account is abstract, cannot be instantiated. So that is important point actually. So abstract classes can't be instantiated, right? So I told, right, any class can be made abstract. Why? So you want your class cannot be directly instantiated by anybody. You write a class, a student, customer, whatever it is, and you want to force, you want to restrict someone not to create an object of your class, then you make it abstract so that nobody can straight away create object of it. Okay, yeah, that's the use. Any class can be made abstract. So you want to enforce one restriction, so nobody wants to create an object, we can actually do it because abstract classes cannot be instantiated. So now this abstract classes contains both abstract methods and concrete methods also, that we understood in the last session, right? We can have abstract methods and concrete methods. Concrete methods are the methods which have behaviors, business logic. So now if you could not able to create an object, then how do you have those implementations getting executed? So for that, there is a fifth point. So when you have an abstract class, just like ATM specification, so there exists somebody called bank. What the bank has to do is bank has to extend that particular abstract class and provide implementation for all those methods. So there should exist a class that should extend, that means inherit that abstract class and provide implementation for all the abstract methods. So that's what abstraction says, right? You have specifications and you have implementations. So using abstract class, you will specify who are doing implementations. There should exist a class that should extend this abstract class and provide implementation for all these abstract methods. So that should happen actually. If this class fails to provide implementation for any one abstract method, then this class also should become abstract. When a class extends abstract class, the class responsibility is to provide implementation for all the abstract methods. If it fails to provide implementation for at least one abstract method, then it also should become abstract. Okay. And finally, abstract class can have all data members, methods, abstract methods, concrete methods, constructors, etc. So these are the details about abstract class. Only this. Okay, a class can be made abstract if it contains abstract method mandatorily, and abstract classes cannot be created, and you need to have some other class which extends this. So in order to understand this, let's actually go to a class. So we are discussing ATM, right? So let's actually go and understand the implementation straight away. So we have an ATM where some abstract methods and concrete methods are available, and some bank wants to have ATM, so it has to extend and provide implementation. So that's the concept, which we discussed in the previous session, right? So now class ATM. So I have one abstract method withdraw. So this is how we will specify the abstract method: abstract void withdraw. If you want to make public, you can make it public, otherwise it is default. And I have another method called deposit, and I have a concrete method. So this is the concrete method. So abstract class can have both the methods, concrete and abstract. So now what is the percent of abstraction? In a class, you have three methods. So out of three, one is concrete. So what is the percentage of abstraction? So 2/3, right? So 2/3 is the abstraction. So 2/3 is somewhere around 66%. 66% of abstraction is there. 66.6. Okay, so out of three methods, two are abstract. So 2/3 of abstraction. So this is my class. Okay, this is my class and two abstract methods, and I have one concrete method, and the behavior is, it says I am an ATM. Okay, so let me compile this Java C ATM.java. Okay, so it will not get compiled now because the rule ATM is not abstract and does not override abstract method. So when this class has abstract methods, so immediately you have to make this class as abstract, right? So you must have to make this is abstract. So that's what we have understood so far, right? A class contains at least one abstract method, it must be made abstract. Yeah, so that's why compile is giving error to us. Now let me compile. Now it will get compiled fine. So if you want to see the bytecodes, now you can actually say Java P ATM, and you can actually see you have one constructor because default constructor is applied, and two abstract methods and one concrete method. Okay, so now this is the specification. So there should exist a class that should extend this abstract class and provide implementation for all the abstract methods. So that's the rule actually, right? So somebody specifies, somebody takes a contract to fulfill it. So now there exists a bank, public class bank. So what it should do is it should extends this ATM. So whenever it extends, right, it has the responsibility. It has the responsibility to implement. It has the responsibility to implement the abstract methods. So if it is not implementing, and straight away you try to compile this, let's see Java C bank.java, you are going to get a compile time error because bank is not abstract and it's not providing implementation for those methods, deposit method, withdraw method. So it's not providing, right? So that's why it is giving an error. So now the primary responsibility of this bank class is to provide the implementation for these methods. So when it provides implementation, they are no longer abstract. So just provide the implementation like this. Even empty implementation is also an implementation in Java, right? So if you say here, this is an implementation only. You are providing implementation. So just to prove this, empty implementation is also an implementation. Let me save my class bank, Java C bank.java, and here there is no compile time error. So that means now you are providing the implementation. Empty implementation is also an implementation, but what I'm doing is just I'm writing some lines actually. So system.out.println is a withdraw method. So I say withdraw success. Okay, and in the deposit method, I am just saying system.out.println. So I can actually say deposit success here. Okay, two methods. So when you extend, what happens? You will get all the parent class methods which are non-private. So everything is non-private only here, and you will get disk method also. So you can actually override the disk method. So now I am overriding the disk method. So you know what is overriding. So I will take this class as it is because signature must be same, and I override the behavior. So I use this override annotation, and instead of saying ATM, I am bank. Right? So this is how we can actually have a class that extends the abstract class and provide the implementation. Now I can have my main method also here. and I can create now which object? Bank object. I cannot create ATM object. ATM is abstract. But what can happen is you can actually say ATM A1 equal to a new bank. So this is possible, right? So we understood in inheritance. So parents can refer to their child objects. So here the object I am creating is bank object only, right? But it is pointed by ATM. We have to do like this only, because what are all the methods you have here in the bank class are ATM's methods. So whatever the ATM withdraw method, it's a method of ATM, right? And you have a deposit method, and it's a method of again ATM, and a1.disp, and of course you are overriding, but it's there actually in parent class. Fine. So usually we do like this. So this principle actually, parents can refer to their child objects. This is called upcasting, and this upcasting we have understood clearly. So in interfaces and abstract classes, we use this abstraction, this upcasting only, because this class implements some other class methods. So these methods are not actually bank class methods. They are methods of ATM class. So just refer them with ATM only. Okay. Okay, I will tell you one more point here once I run this. Yeah. So now I have this methods implemented, two methods implemented. I have one child specific method also aware, sorry, no child specific method. The overridden method is also there. And we have finished the program. So let me now compile and try to execute also. It's compiled fine. So now when execute Java space bank, now I will have all the implementation. So withdraw success, deposit success, I am bank. So it's not ATM. It's not ATM. It's a bank actually. Okay, it says I am bank. Okay. So here you want to print I am ATM also. What you can do? So here you can always use the super keyword, right? Super dot disp. You can always use super keyword. Super dot disp means it calls the parent class. This method, you have a parent class that is ATM. And when I say super dot disp, it says I am ATM. So let's see. Let's see, that's the overriding I am doing here. Java C bank dot Java, and you can actually run. Now you can also see I am ATM and I am bank. So this method is overridden method. It actually have its own behavior. So if at all parents behavior, always you can use super keyword and you can get it. Okay, so this is the example. So basic example for abstract class. Okay, how we are making a class as abstract, and yeah, what is abstract method? And because we can't create objects of it, there is somebody that should exist. So that's what realization actually. So what is realization? Realization is the relationship that exists among different components. So here I have abstract class ATM and I have a class. The relationship among them is realization. One specifies the contract and another fulfills it. So which is specifying the contract? ATM. Which one is fulfilling? Bank is actually fulfilling. Fine. So this is one example. And let me tell you one more thing here. And this child class bank, right? So can have its own methods as well. It can have its own methods. Let's say, so there is a method called fun. Okay, so just it says it's a child specific method. It's a child specific method, right? So this method is not there in the parent class. This method is a child specific method, right? So now can I call like this a1 dot fun, a1 dot fun? No. So this is a compiled error. It's a compiled error because a1 is actually referring to ATM abstract class, and fun method is not there in ATM, right? So you cannot call actually a child specific method with a parent reference. Any method which is defined in the parent, you can call with the parent reference, but any child specific cannot do it. So in order to understand this, let's compile this Java C bank.java, and here you cannot find symbol because with A1 it could not able to find the fun method. So that time what is required is you require a child specific object. So then definitely you have to say bank B1 equal to a new bank, and then you can actually say B1 dot fun, then B1 dot fun. Okay, let me compile this. Now it got compiled, and when I run, it will run also, right? So this is one important point to be noted. So whenever you have a child specific method, that cannot be called with a parent reference. Fine. Yeah, so in order to make a few changes to the same code, what I'm doing here is, here I have just methods only, right? So there are no constructors and there is no data. There are no constructors and data. So now what you can do is, I can have certain data. So for example, I am in the context of ATM, and let us assume here ATM has some interest rate defined for the value that is deposited. So double interest rate. Okay, double interest rate. Okay, so I have some interest rate. So that means whenever somebody deposits some amount, so we will give some interest rate. Let us say. So since I have interest rate, right? So I can actually have my constructor that is constructing this interest rate. So I want to show this example where I am using everything which are possible in a class. That means abstract class can have data members, can have constructors, can concrete methods and abstract methods. That's the idea. So now this dot interest rate equal to interest rate. Okay, so this is my constructor, right? Yeah, so now abstract void withdraw and abstract void deposit, these are the abstract methods, and this is the display method. Fine, actually. So now let me make my ATM class compiled and ready. Yeah, Java C ATM.java compiled successfully. And then now my bank class is extending ATM. Now my ATM class must have a constructor because my bank class must have a constructor because it's extending ATM and ATM has a constructor, right? So now let's assume this child specific class, the child class, the bank also have some data, let's say cashback. Okay, it has certain cashback. So whenever you withdraw, you are going to get some cashback. Let us assume like that. Okay, so now, so this is a child specific thing, right? This is a child specific one, right? And along with this, what you have already interest rate getting acquired from ATM because it's not non-private, you will get it actually, right? Interest rate. Okay, uh, from parent. Okay, so now since my parent has a constructor, I should also have a constructor. So let me write public bank, and I need to construct both the values. So double interest rate, comma, int cashback. Okay, so in my constructor, so first line will be super because I need to construct my parent variable first, the child object, and then this dot cashback equal to cashback. So this is what we understood already, right? So how to use super and how to, whenever you have inheritance, how to invoke the parent class constructor. So that stuff actually, right? So now void withdraw success, and what we do is we will also say withdraw success, and we will say you got cashback, you got cashback. How much is the cashback? So that cashback is actually whatever the cashback that we are going to set. Okay, so we will say congrats, you got the cashback, you got cashback of so and so. Okay, just I'm using this data. So whatever the data which I have in my parent class and my child class, the deposit success, and what we say here is we will say you got interest rate. Okay, so congrats, you got interest. Okay, so interest at what percentage? So interest at this percentage, actually whatever the percentage, whatever the interest rate we are giving, so that interest rate is getting. Okay, so both the values I am using in my implementations. The this method I am calling my parents super.disp, and here. So now the fun is a child specific method, and when I Okay, so when I create ATM A1 equal to new bank, so I need to pass how many? Two parameters, right? My bank construct has interest rate and cashback. So interest rate is, let's say, 8.5, and the cashback is, let's say, some 30 rupees. Okay, so this is how I am constructing. So A1 dot withdraw, A1 dot deposit, A1 dot disp, and bank V1 equal to new bank. So here also I need to pass the values. Actually here also the same interest rate and the cashback I am giving. So here the idea is your ATM has data members, methods, concrete methods, abstract methods, and the constructor, and how you are actually writing the other class that implements the abstract method. So the primary responsibility is to implement these two things, right? If you tell, if you want to override, you can override it. You can have this class can have child specific things. It can also have child specific things. But importantly, when your parent has a constructor, you also should have a constructor, and now everything should be fine, right? So let me now compile this. So Java C bank.java compiled successfully because everything is fine. And when I say bank, then I will have all the details. So withdraw success and you got 30 cashback, and deposit success, you got interest at 8.5. And this method, I am ATM, I am bank. So I am ATM is super.disp, and we are calling a child specific method with the child object. Okay. So this is about abstract classes. Very simple. Abstract class is so simple. So if you understand these points, then writing specifying abstract class is so simple, and implementation is also easy because we know already the inheritance concepts. So if you understand this abstract class well, the next topic is interfaces. That's going to be so easy because interface has all abstract method, 100% of abstractions. Okay, so I'll see you in the next session. Thank you.